Okay, here we go. We are on page 353, lesson 7.3. We're going to talk today about elimination. So let me show you an example. This will be the third method you've learned and how to find where two lines intersect. The first method we learned was graphing. We graphed the lines and we looked for the place where they intersected each other, and we named that location using X and Y.
Your network kind of reminds me of a type of game mode.
Yeah, a little bit. Then we learned about substitution. Substitution was where if one of the letters was isolated, we substituted its equation partner into the other equation in place of that letter, and we solved, and we ended up figuring out what one of the letters was, and we go back and plug it in. Two examples of that. Sometimes it's really easy, sometimes you have to be a little more careful. This is the third method. Sometimes kids really enjoy this method. They think it's better than the other two. Maybe because they think it's easier, or because we've done this and this is the third thing that I teach you to do. By now you're kind of figuring out and feeling more comfortable with the whole concept. But the very first problem we're going to look at says 5x minus 6y is equal to negative 32, and 3x plus 6y equals 48. Elimination is the best method to use when both of your equations are ordered the same way. So the very first thing I want you to check is the order. For example, this one says x, then the y term, then the equal sign, and then the regular number or the constant. And this one is in the same order. It would be a lot of work on me to rearrange this and isolate the y and then use it in substitution. I would have to do quite a bit of work before I ever started. Now, this is the only time that you're going to be adding equations together. But that's exactly what we're going to do, is we're going to line up these equations so that these parts match. We want the x's together, the y's together, and the regular numbers together. So we're going to add them just like we would add numbers in elementary school. What happens when you add negative 32 and 48? You get 16. What happens when you add negative 6y and 6y? What happens when you add 5x and 3x? So essentially, you have 8x is equal to 16. So you can divide by 8, and x is 2. So you have found the first part of your answer. Now, your choice as to whether I plug that into the first equation or the second equation. Doesn't make any difference. One's not any easier than the other. Which one do y'all want to use for this example?
I'm doing all the positive.
Okay, the second one, because it's all positive. So that 2 goes right there. 3 times 2 plus 6y is 48. What's 3 times 2? What's the next step?
Wouldn't that be 6 and x? Oh, you're replacing x, right?
What's the next step? What do we get here? Divide by 6. What's the value of y? 7. Okay, let's check it and be sure it works. In the first equation, 5 times 2 minus 6 times 7. I'm checking to see if it's negative 32. And it is. Second equation, 3 times 2 plus 6 times 7 is 48. It works in both.
The same self-explanatory, except when getting the fraction.
Okay? Does anybody have a question about this example? Okay, let's do another. It says 6x minus 3y equals 3, and negative 6x plus 5y equals 3. write it on your paper. Now the first thing I'm going to ask you is to check and be sure that these two equations are ordered in the right order. Is it x, y equal sign numbers? That's the order we're looking for. If it were y first, it would just need to be y first in both of them. I don't care what really the order is as long as it's the same. This is the order that you're going to see most often. X term, y term equals sign number. Now, let me ask you the second question. If you were to combine these two equations, will one of the variables eliminate?
Yes.
Which one? The x. Okay, so let's add them together. And we get 0x. And what do we get here? 2y is equal to 6. Divide by 2. Y equals 3. So I have discovered that the y value is 3. Which equation do you want me to use now to determine x? Okay, so this 3 is going to go right there. 6x minus 3 times 3 equals 3. 6x minus 9 equals 3. What next? Okay, and then I need to, okay, and x is 2. And that's the right answer, and if you didn't know it was the right answer, you can check it with your calculator. Okay, any questions so far? Y'all liking this so far?
I'm liking this way better than, what's the other one?
Substitution.
I like it better.
Okay, let's look at the next example. This is example 2, the second type of problem we're going to see. Write that on your paper. It says 2x plus 5y is negative 22, and 10x plus 3y is 22. None of the variables will cancel out. Don't be tricked, because the numbers will. 22 and negative 22 will give you 0, but if you were to add them just exactly the way they are right now, you get 12x plus 8y equals 0. And that wouldn't help me. I wouldn't be able to figure out x or y from there. So sometimes when they give you the problem, you have to do a little work before things will eliminate. Now, if I look at that problem, I think it sure would be nice if that 2 were really a negative 10, because that would make the x's disappear or eliminate. What could I do to change 2 into negative 10? Okay, so I'm going to have to multiply everything in the top by negative 5. I'm going to rewrite it down here. It's going to be negative 10x. I multiplied right there. Got negative 10x. Plus negative 25y. Are y'all following along with me? Every little item in that top equation has to be multiplied by negative 5. What is negative 5 times negative 22? 110? Okay. The second equation remains the same. I just recopy it. And now I have something that will eliminate. My x values will eliminate, and when I combine those, I get 0. And here I get negative 22y equals 132. And what do we do next? Divide by negative 22, and y is negative 6.
Oh, that's negative 22.
We good?
No, I know.
Everybody good?
I just got confused by the other 22.
Okay, well, she's just trying to help you out. What's the next step?
Would that be placing?
Plug it in. Right, Jonathan. So I'm going to plug that in. I'm going to use that bottom equation. 10x plus 3 times negative 6 is 22. Add 18. 10x is 40. Divided by 10. And x is 4. We good? Any questions on that one? Next example. Okay, this is actually example 4. I'm kind of skipping around today to hit the high point, and tomorrow we'll catch up on the other things. Look at these two equations. They are in the right order, x, y, equal sign number. Will anything eliminate as it's written right now? No. I've got 4 and 7, 2 and 3. Is there a nice, simple, easy trick to turn 4 into 7 or 7 into 4? What about 2 into 3 or 3 into 2? I'd be multiplying by fractions to do that. Nobody likes fractions, so we'll try to stay clear. So in this case, you're going to have to do some work to both equations. Okay? That little trick a while ago where we multiplied everything by that -5, I'm going to have to do a little work to both equations. You get to pick. I don't care whether we turn 4 and 7 into 28 and -28, or whether you turn 2 and -3 into 6 and -6. Which do you think would be easier to do? The 6, because the numbers are smaller. So in order to turn 2 into 6, what would I need to multiply this by? 3. And in order to turn -3 into 6, what would I need to multiply, or into -6, what would I need to multiply this by? 2. Okay? So you're going to have to work on both equations. Please be careful. That's all you really have to do, is be very careful. Distribute here. I get 12x plus 6y. 3 times 14 is 52. Last time I checked. Is that still right? 42. 42? It changed. How did it change on me? Is it Monday? Okay. 2 times 7 is 14x. 2 times -3 is -6y. What's 2 times -8? -16. Okay, so we've got them both adapted. Now what's going to happen? What's going to disappear when I combine these? 6y's will go away. So let's combine our equations. 12x and 14x are going to give me what, guys? 26x. These are going to eliminate. What about the other side of the equal sign? 26? Okay. So what do we do now? Okay, divide both sides by 26. So x turns out to be 1. Now, what you found is the x part of that coordinate. What's the next thing you're going to have to do, Jared? The y coordinate. How are you going to figure out the y coordinate? Tom? Plug it in. Which equation do you want to use? Okay. Please use the original. Okay? Use the original. We're going to use the top original equation. So x gets replaced with 1. So 4 times 1 plus 2y is 14.
What was that?
That was the phone, but we're going to turn it off. I think it's Mr. Wallace. Now what do we do? Okay, subtract 4 from each side. 2y is 10. Divide by 2. What's y end up being? 5. Okay, let's check it using our calculator. Everybody get your calculator out.
I don't know what to say.
Did you catch on with me right here?
That's why I kind of stepped back to fix it.
Okay. So do you have this line right here?
I do.
Okay.
Why does that make it 4?
Well, 4 times 1's 4, right, Braden?
Mm-hmm.
So we subtract 4 from each side. You caught up with me?
2y plus 5.
That's right. Okay, so we're going to try the first one. 4, we're using the original, okay? 4 times x, but what did we figure out x was? Okay. Plus 2 times 5. What are we checking to see? If it's 14, that's what it's supposed to be. Does it work? Yes, but it has to work in both of them. So you better check the next one. 7 times 1 minus 3 times 5. And what's that one supposed to be? Negative 8. Any questions on elimination? Okay, let me give you your problems for today. Page 356, 1 through 14 all.
What were they doing?
They're just observing to make sure that we're all doing what we're supposed to be doing.